Right, so this is how to apply the binomial theorem. And in this case, we're finding the value of the coefficient of x squared. So we don't need to include x squared in our answer, we just need to find the coefficient in front of it. In this expansion, x divided by 2 plus 2 divided by x quantity squared. So the first thing I'm going to do is I need to think about what combinations of exponents will equal x squared when I divide. Keeping in mind that whatever I do to 1, right? So if I say the exponents have to add up to 6. So if I make this term x to the 4th and this one x squared, well, 4 plus 2 is 6. So that works. And in fact, I think that is the exact answer, because if I do this, if I say x divided by 2 to the 4th, that means in the numerator I have x to the 4th, right? Over 16 times 2 divided by x, and then if I square this, right, that ends up giving me 4 divided by x squared. Well, when I look at my x's, I end up with an x squared, so this works. Okay, so basically what I need to do from here is I'm going to say I have 6 terms, or I have a power of 6, and I'm choosing 4, because this is the 4. Okay, so that's how I get my Pascal's number. And then I go ahead and I do this, right? Okay, so, you know, in my calculator, 6 choose 4, let me see what that is. Oops, that's the right one. It's 15. So 6 choose 4 is 15, times I have x to the 4th divided by 16, times 4 divided by x squared. And if you're wondering how I got 16, remember exponents apply to the numerator and to the denominator. 2 squared here and x squared here. Okay, so I'm not interested in this being x squared except for, you know, to know for sure that it is. So I end up with, I'm going to reduce this really quick, cross reduce. And if you don't want to cross reduce, you don't have to, but I think it's easier. 4 goes into 16 4 times. So I end up with 15 divided by 4 x squared. So my answer is the coefficient of x squared is 15 divided by 4.